My name is Eugene Talley. I'm one of the professors here at SIU Automotive Technology. And today we're going to take you for a tour through our Transportation Education Center and show you where we get to work every day and where the students get to learn and become leaders in the automotive industry. Come over here, I'll show you a map to kind of give you an idea of what we'll be walking through today. Here at the Transportation Education Center, we do share this space with aviation, one of the top aviation programs in the country. But in this particular building, they really only have 2 dedicated spaces.
Hello everyone, sorry for the delay. I got carried away and I was going through and using OBS, which is the software that kind of does all the streaming, and I went through and made all this fancy scenes with overlays and all these different things, and it bogged my computer down so much that everything was super choppy. So if you saw in the last few minutes, I was deleting scenes because I didn't know what was causing it. You don't know anything until you get ready to go live and you upload this stuff and you start previewing it, and then you see it's not working. And I know it worked last week when we did the rear axle stuff. So anyway, unfortunately, all that extra stuff I worked on I won't be able to show you because I had to delete it all just to make this stream smooth. But what we're going to do today, and just as a preface, we are, or I am doing all this stuff here in addition to the lectures that my students are doing online on D2L, Brightspace. They go through and they're learning transaxles, clutches, that kind of stuff right now. And so this live stream is really there to kind of support what they've learned. They've been watching these static lectures going through. I've got a lot of video in the lectures, but this is a situation where they get an opportunity to maybe ask me questions if they need and so forth. So I got Mike Bierman back there. He's managing the console, or not the console, but the cameras, the connections and everything like that. So if something doesn't work, send him an email saying it didn't work because it's probably his fault. We'll just go ahead and leave it at that.
In the chat section.
Yeah. Well, we'll watch for the chat section. So hopefully you guys can hear me okay. Maybe put something up there saying the audio's coming in okay. There is a lag if you've ever done this live stuff. I've got 2 screens up. I'm looking at YouTube on one side and Facebook on the other, and there's about a 15-second lag. So, but I don't want to be up here talking and nobody hear me. So if somebody could say, "We hear you all right," that'd be good. Okay, good. So the first thing I'm going to do is kind of show you a few of these mock-ups that we've got and describe what's going on in the transmission. So I'm going to have Mr. Bierman here carry the camera over, and we'll start over here. Kind of, this is a rear-wheel drive transmission that was from a Chevy truck, and I like cutting things away. I got a lathe and a mill and all this stuff, and those of you guys that know me, I like to take things that are perfectly fine, cut them up, and pretty much make them useless. So, but they're good training aids. They show people what's going on in the transmission. And here you can see it's a rear-wheel drive fashion, so we'd have an engine up here, transmission, and then it goes to the transfer case. It's 4-wheel drive setup. You might have remembered it from the last video. I am missing a shifter, so I've got a makeshift shifter there. But when you're shifting a transmission and going back and forth, you're letting a shift fork, a shift rail is moving a shift fork, and it's engaging these gears. So this is a constant mesh transmission, and right now it's a neutral. So if I were to, well, the output shaft might not be turned. I can't tell, I'm not on the other side of it, but there's nothing going on here that's delivering torque out to the vehicle. Basically, when I shift, I'm going to select one of these gears and lock it to the main shaft. And the main shaft is going to be the output of the transmission. So when I'm shifting between gears, the thing that I'm doing is I'm moving my synchronizing sleeve, which is this piece here. I'm sliding it over and it's grabbing onto these teeth on the gear. So these little teeth that are right next to the big gear, in this case this is 3rd gear, that the sleeve locks onto those little teeth. And then torque will transfer through the sleeve, through the teeth, to the gear, and then to the main shaft. So if I were to go through and wrong one, there we go. If I lock that gear to the shaft, if I lock that gear to the main shaft, that's the gear that's being selected. All these others are going to be left disconnected as if they were in neutral. And they spin, but they don't spin at main shaft speed. They spin at their own speed because this is a constant mesh transmission, so everything is constantly meshing. Now if you take a look here, this is that reverse idler gear. My input's going to be going clockwise, my counter gear, driven gear is going to be going counterclockwise, and then a normal speed gear like we were talking about third, this would be going counterclockwise, the third counter gear, and then the third speed gear would be going clockwise. So it's clockwise, counterclockwise, and then clockwise. Well, to get reverse, I need to reverse that. So that's where this idler gear comes into play. And in order to get reverse, I'd have to put this transmission in back into the neutral, wrong way. There we go. So now I'd lock this speed gear, the reverse speed gear, to the main shaft. So torque could come in from the input shaft to the counter gear, driven gear, to the reverse idler gear, to the reverse gear, and now my output would be turning in reverse. All right, let me show you this transaxle. We've got, we made this cutaway here. This is out of a Mitsubishi Eclipse that used a Chrysler powertrain. And Ethan Doty made this and did the cutaway and some of the stand work and so forth. And a transaxle is really the same thing as a transmission. It is a transmission, but it's similar in operation to the rear-wheel drive transmission. What's going to make it different is that we have the final drive assembly in it, and the way the shafts are set up are a little bit different, but we still have synchronizing assemblies, we still have shift forks, torque is still going to transfer through it. We're going to be locking gears to the shaft just like we would on the rear-wheel drive. Now, we have two, if you look up here on these two levers, one of these levers is going to be responsible, like this one here, a cable would be hooked up to it. So when I shift the transmission side to side in my shift lever side to side within the neutral gate, basically all I'm doing is moving this back and forth. And when I go forward and back, I'm moving this shift lever back and forth. So I can select, like if I go over to first and up to second, or over, like in the neutral gate, if I move over to the 1-2 area, maybe, and I'm not really certain which direction this is. Let's see if I'm, yeah, that was, so this would be like first and second. I know you're probably not seeing anything going on in there because the first and second is on the other side. And then when I move the shifter into the middle, where I'd normally be operating third and fourth, they'd be in this position. That's third, that's fourth. Then when I move it over another step further, I can get, oh, that's reverse. I can get fifth. And then if you notice down here, there's that reverse idler gear. This has got a slider type reverse gear where I actually slide that gear in and out of engagement. Okay, so if you have questions, and we're away from the computer right now, but if you have specific questions on this, we can go back and look at that in a second. It's always here. Now over here, this is the clutch assembly. So I made this mock-up. We kept the crankshaft out of the engine, the flywheel, the pressure plate, and in here you can barely see the clutch disc. And when I'm pushing my foot down on the clutch pedal, you'll see the clutch disc, the pressure ring and the pressure plate pulls away. Is that going to be blurry? Or?
Oh, got it.
Okay, good. So that pressure ring pulls back away from the clutch disc and releases it. Might be easier if I left it in a gear. So you can see the clutch disc isn't spinning. It might be dragging a little bit, but so in there, that clutch disc is released. I take my foot off the clutch pedal and it gets squeezed, and now I'm delivering torque. You can see the amount of movement on that pressure ring. If you look on this release bearing here, that's pushing on the release fingers, and that action pushes the pressure plate away from the flywheel. You need about at least 80 thousandths of movement of this pressure ring. Usually you'll get more than that. If I put my finger up against this pressure ring as reference, I don't know if I'm getting an eighth of an inch, but I'm getting close. And there's a lot of things flexing and moving around on this. So yeah, post questions up on that. If you look, I know you haven't gone through, students of mine, you haven't gone through the clutch systems and all that stuff completely. Maybe you can, when you go through it, you'll get a little preview of it. But this is the hydraulic clutch system. So the hydraulic master cylinder is right here. This is the clutch master cylinder. So when I push my foot down on the clutch, I'm moving a piston that's in this assembly here, and that's going to push fluid through these lines over to this slave cylinder. And this is an external slave cylinder. Sometimes they put them in the transmission right here, right around the input shaft, but this is an easy one to service because it's external. This is the bleeder screw, so you can get air out of it, because obviously if you've got air in it, you need to get that out, because air doesn't like to be, it doesn't move like a solid in a sense. It doesn't, it's not, air can be compressed, whereas fluids cannot. So if there's air in there and I'm pushing my foot down on the clutch pedal, I'm just squeezing bubbles. Sounds like fun, but that's not what we're trying to do. We're trying to have movement, fluid movement, right? So then that pushes on this clutch release lever, and then there's a pivot point in there, and then that pivots and pushes on the release fingers on the pressure plate. So 99% of vehicles that you're going to see are going to have hydraulic clutch systems. Very common. So where is this going? Okay, let me go ahead and show me, Mike. Hello. All this manual transmission stuff, it probably accounts for just a few % of vehicles sold in the U.S. Obviously, in other countries, manual transmissions are more common, more popular. They're really just kind of used on sports vehicles that we have here, maybe trucks. If we get older vehicles, I mean, even trucks nowadays don't use them. You have to get into the 90s and maybe the early 2000s to find trucks because they quit putting them in because the durability of them, they can't handle diesel engines and so forth. They seem to rattle themselves apart. Now, when you get heavy duty, they still have manual transmissions. And then right here is an Acura 8-speed dual clutch transmission. And you're starting to see a lot of manufacturers switch to dual clutch designs. It's a manual transmission internally, the way that works. We still have shift forks and we have helical cut gears. We still have synchronizing rings, sleeves, all that stuff. The difference is you don't have the shifter and you don't have a clutch pedal anymore. The computer, the vehicle's computer is going to take over that. This is a mock-up I made of it. I could show you how it shifts. If you take a look, I operate this with air pressure instead of hydraulic pressure, but they use these hydraulic pistons to move the shift forks and sleeves back and forth. So imagine hydraulic pressure doing this instead of air pressure. It's shifting, it's locking this gear to the shaft, locking that gear to the shaft. It's a little hard to find neutral sometimes. And then we got same thing here. Okay, trying to find neutral. Sometimes if I got too much, there we go. If I got too much pressure in here, it won't find the neutral. And then I have another shaft right down here that has, I don't have air hooked up to it, but it also has synchronizing assemblies. The pistons for it are in the back of this valve body. All these hydraulic controls, look at all the solenoids that we have on this, and these are all different solenoids to control pressures and then control the shift forks and the line pressure in this transmission. So we're manually shifting, automatically shifting a manual transmission. So the manual transmission didn't die, it just took the driver out of it. It took the manual part out of it. Mechanically, they still use this system. It still does what it does with the shift forks and the sleeves, synchronizing rings, the whole works. And so, yeah, this is something different. It's not something we normally cover in the drivetrains class, but because a lot of people are thinking a lot of drivetrains related stuff's not so relevant anymore because there's just not many out there. Well, that's not 100% true because we've got automatically shifted manuals. So you're going to do some of these same measurements that we do to a normal manual transmission, you'll be doing here on these automatically shifted manuals. Even this right here, this is an Eaton dual clutch 7-speed transmission. So even in the big dogs, the big units here, I guess I could have spun this around beforehand. Didn't think about it. Those bolts are kind of tight. But you can see here, we have a manual transmission with synchronizing rings. This is the type that would go into like a dump truck or something big. It wouldn't be in a semi, but it would be in like a box van or a box truck. Not light duty vehicle, not an F-350 or anything like that. You'll find these things in like a garbage truck or a dump truck or something like that. 7 speeds, and they, just like the Acura, they have a dual clutch design. They drive 2 different shafts in this transmission, and they have half the gears on one shaft, the other half of the gears on the other shaft, and they electronically or computer controlled shift this transmission gear to gear. So this is another mock-up we're making, And in this case, the dual clutch, they actually, and I don't have it here, it's sitting on a bench, but the dual clutch assembly sits in here. It's a wet clutch, it's filled with fluid, and they switch between these two shafts. On one shaft, they're going to have first gear, third gear, fifth gear, seventh gear. On the other shaft, they'll have second gear, fourth gear, and sixth gear. So when they shift in the first, they can pre-shift you in the second, and then all they have to do is switch clutches from one clutch to the other, and they go back and forth. So the industry is changing. The reason why they are doing it that way is because they fuel economy, and you know, the manual transmission is great, and it's been in trucks forever and a day, but they're trying to, for shift quality, comfort, strength, reliability. Also, you don't need to be, as a driver, you don't have to be as trained to be able to operate an automatically shifted manual. As you know, a lot of the manual transmissions and heavy-duty trucks, they're not synchronized. You have to speed match. You have to do that kind of stuff. Here, the computer does it for you. It controls the speed, adjusts the speed so it knows the shafts are going close to the same speed, slides the synchronizing assembly over, locks it up. Now, that one is synchronized, but my point is that a lot of these advancements are there for fuel economy, emissions, durability, and for ease of driving. So anyway, let's go back over here to the bench. Let's see, that Tran's got a no yo-yo shift kit. No, Mikey, it doesn't. A comb forward, whoa. I have a feeling Jason Russ is talking about my hair. I know it's gray. I dye it that way so that way I get respect. It's hard to get these days, so I figure I better get it where I can, right? So thanks for tuning in, Jason. But we're going to take apart this Acura. It'll be interesting because normally I'll be having things aiming towards the camera, and it's not obviously the direction that I would normally place things. So, and I do have a couple like booms and so forth, so we can show some camera angles. I had this thing completely set up, but then my computer bogged down, as I mentioned at the beginning, and I had to delete some scenes. So unfortunately, things, because I had this set up right here where on my phone I can go through and select all these different scenes, so it's probably not going to be quite as smooth as I had hoped. I'm going to have to go back to the old-fashioned mouse trick here and see if I can find my, put this on paper, that sounded horrible. I got to find my mouse. It's the scroll wheel. Just going to mumble to myself for a while. Okay. And all right, so in front of us right now we've got this Acura 6-speed. A lot of times before you take a transmission apart, you're going to want to go through and make sure it shifts, see what it feels like. So you can grab the input shaft. Like, you know, you can see it spins. That's a good sign. These things have been apart many times, so we can't always assume that whoever put it together before us did it properly. And just like that Chrysler transmission on that mock-up, you can see that I've got two shift levers, or two external shift assemblies. Look at that, all right, dirty. Two shift assemblies external on this, outside of this case. This one here is going to be me taking the shifter, moving it side to side in the neutral gate. This is a 6-speed, so I'll have 1, 2, 3, 4, 5, 6, and then or just reverse will be kind of off on its own. So if I push it over in one direction, I'm going between the 1, 2 synchronized, first and second gears. I'm moving the 1, 2 synchronized assembly back and forth. And I can spin it each time just to make sure everything is moving smoothly. Then I let this go over a little bit, and let me go ahead and I'm going to switch to the boom here. So I'm basically letting this go over a little bit. This was when I had it in first and second. Gonna let this fall into the 3/4 section. I could spin the shaft, make sure it's spinning each time, kind of feel for any roughness. Then I'm gonna move over to the 5th and 6th. I just pinched my finger. Checking to make sure it shifts okay and rotates fine. And then I pull it all the way over and make it shift in the reverse. And you know, so I can get an idea of if there's any roughness, difficult shifting, that kind of stuff. And it's good to know because that gives us something to look for when we go back in or when we go together with it. Okay, so now on this thing here, on this Honda, I got these cores, by the way. So if you are a school and you're listening and you're struggling to find automatic or manual transmissions, it is difficult. I know, because there's not many out there. And I like these Hondas because they're pretty easy to come apart and go back together. And Honda's one of those few manufacturers that actually does make quite a few vehicles still with automatic or manual transmissions. The Accord, the Acura TL, up until they stopped making it, had it. And then the Civic, you know, those vehicles right there have a number of manual transmissions. Matter of fact, this is, I believe, a 2004, and I have it written down on there just so we can, you know, look for service information every time we pull it out. I didn't know what it was when it came in. A lot of times the Hondas put a VIN tag on the outside, which is nice because then you could just go through and search the VIN tag and figure out the application. I wish all manufacturers did that. It would be nice. I don't remember if this one had one or not, but I don't see one. But a lot of the, like I said, a lot of them have a riveted VIN tag to it, so it's easy to identify. But also, they're easy to come apart relatively. The hardest part is getting the case on. And if you look at this 2004, which I assume it is, and you look at 2010, even you look at the 2020 Accord, and you look at the service manual, visually it looks identical to this unit. And if you go to Civic, they've got two different types of manuals, one for 1.5 liter, one for their 2 liters. And one of them is identical to this, or I mean visibly, the way it's designed. You could, I'm sure it's not the exact same transmission. Matter of fact, if you start searching parts, you'll find that they must change gear ratios and that kind of stuff, because a lot of times they have specific part numbers for specific units. But my point is if you go through this transmission on a Honda, you're getting experience on pretty much all their 6-speeds. And even if it's as old as 2004 or as new as 2020. So that's nice. It's not common that you can do that. So I'm going to take some of these bolts off on this thing here. Right here, I'll show you. Let me see if I could switch to this camera on the side. Oh, that didn't work. It's interesting. Okay, there we go. Right here on the side, you can see I've got these, oh, not that one, but right here, 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 here. Is there another? This one down there. And I don't know, there's 6 of them. They're basically, they're detents. They are these check ball, use a 12 millimeter. Normally I don't let the students use electric tools because I don't want them to strip things out. But basically what you'll find is you're going to have a kind of a spot with a spring, and in there's a check ball. A lot of people forget about that and they take these out, oh, they got little springs back there, and then they tip the transmission over and the check balls go rolling everywhere. You know who you are if you've done that before. So I don't have, oh, there it goes. I don't have a small magnet that fits in there, so there's a little trick for you. Take a magnet and stick it to something like a punch, and it magnetizes this enough. It's not very strong, but it's enough to get stuff out. So I need to pull these out, and the reason why is because they will hang up the, well, 2 reasons why. If you can pull the case off with those in there, they're going to shoot out, or they might prevent you from pulling the case off. So you pretty much have to get all these out. And now one of the things I'll tell you is that there are different sizes of these springs. Like that first one that I pulled out had this gold spring in there. And then this one here on the side, it's got a black spring. If you look, the black spring is shorter than the gold spring. So you want to be aware of that and where those go. The service manual does have that information, but if you're like me, you've found many of instances where the service manual gave you false information, right? And we don't want to always count on it. If we know this has never been a part before, it's good to pay attention to those types of things, because when things aren't working quite right and they don't seem right, they usually aren't, and then when your service manual is not agreeing with what you're finding, you kind of wish you paid attention. There's another one back here.
Can you repeat repeat the detent piece? Again, one of the students has a question.
The detent, let's see, regarding, trying to think, okay, could you repeat the detent thing? My stream froze. Okay, probably, I guess just talking about these in general, these detents, that if I don't pull these out ahead of time and I try to take the case off, two things could happen. One is it prevents my case from pulling off because they get hung up in there. They don't want to get past the shift rails. And also another possibility, especially on rear-wheel drive transmission, they usually have interlock pins. So if one of these check balls starts to get compressed, it locks one of the other shift rails. So you have to get those check balls out. But another reason why is because if I pulled the case off without pulling these things out, the check balls are going to shoot around inside the transmission and I might not be able to find them. They might disappear on me, and that's no good. There's another one. There's 6 of these total. And let me make sure I got 6 in the tray now. And get the check balls out of them. They're all the same size check balls on this. So, all right, and we go back to the tripod view here. I'll be saying that out loud even though I don't have to. I'm not a professional. I'm still figuring this stuff out as I go. This cover I'm taking off here, this basically houses a snap ring that we'll end up having to expand to take off. And I could zoom in a little bit on some of that. So right here there's a snap ring. That's going to end up needing to be taken off here and spread open to let this case come off around it. The snap ring, a lot of people get confused with these snap rings because they see it and they don't realize that you actually have to expand it open. It lives in a deeper groove inside this case. And then when you lift it off, that snap ring stays in the case and it leaves the bearing behind. You'll see that in a second. So yeah, and then one thing I didn't show you is on the side here, the service manual, they'll talk about this, that you should pull all your electronics off. Even if you don't have to, even if they're not holding anything in, it's good because you're going to be rolling this thing around on the bench and there's a good chance you'll break something if you don't do that. All right, at this point I'm going to go ahead and take these bolts off around the case. I probably could have done this earlier. That way I wouldn't have to pause every time I loosen a screw. Because that probably gets pretty annoying for you guys to hear on the other end. Plus now you're just sitting here watching me unscrew bolts. That's pretty tedious. Got one more. For some reason they have to put one with a different size right up in here. And that's the only one that's different. That's something unique with Honda. Honda, I forgot one. Honda is pretty good about, on their automatic transmissions, having 5,000 different length bolts. And a kind of a generic trick is kind of, well, for one, you could always look when you put these in as you're going back together. Before you tighten any one, just kind of look to see if they're all sticking out the same height. And rule of thumb is they stick out about the width of the bolt itself. So if you see one sitting really low, something's wrong. Even if nothing else seems to work in there, then you gotta look at see if maybe the threads are halfway torn out or missing. So that's still a good, even if, like in this case here, we only have one bolt that's a different length, and that's this one. But you still want to put those all in there and kind of look at them before you get carried away and just tighten them all up. There is another bolt right here. I don't really have to take this one out, but I'll go ahead and do it. This Acura is kind of interesting. They've got a filter, which is pretty cool. And they got an oil pump. Most manual transmissions do not have oil pumps. Oh, thanks, Charlie. He says, you're a great teacher. In fact, my favorite. How about you and me take a stroll after class and perhaps, whoa, oh my goodness, Charlie. I don't know about that. I'm feeling cyber attacked right now, but get off of there. This thing's hard to get off because it's got an O-ring on it. And this, I could see this happening. It hasn't happened, but right here, this ear, if you got underneath it and pried it, you'd probably break it. So I had to fight that O-ring a little bit. You might have to get tough with it though. If you take a look, this is a spring and a filter that kind of keeps it all pushed together. And this filter is going to filter out the metal of the fluid because there's a little pump, we'll see here in a second, that pumps all this fluid around and keeps it lubed up. Now I haven't looked in the service manual or in the owner's manual. I should have done that. I was thinking of doing it, I just forgot to. Most vehicles, if you've ever heard, you're really not supposed to like flat tow or pull a vehicle by their driving wheels because you're spinning parts in here. I'd be spinning parts in this manual transmission, and where the most manual transmissions get their lube from is the gears. When they're rotating, they splash oil up everywhere. Well, if you're just cruising down the road and towing a vehicle like behind a camper, you're going to be you might not be spinning all these gears, and you might be starving this transmission of oil, at least in the shafts, because that's how they get their oils, through splash. Now this transmission, as well as others, like there's setups that they've done on certain transmissions, and this one here has an oil pump in it. So as long as these axles are spinning, the differential case is spinning, you'll see there's an oil pump in there. It's going to pressurize and pump oil through it. So my guess is that you're able to flat tow with this design, but like I said, I haven't completely looked in the service manual. I'm going to try to spread this open real quick. I'd say real quick on everything, even though it's not. I get wordy. Snap ring pliers, you might have noticed, probably didn't, but it dropped down and the snap ring stayed spread open. So now when I go to take this apart, I can wiggle it and always double check to make sure all your bolts are out. If this one had never been apart before, you can imagine it's not going to come apart easy because I'm going to have sealant between these. So they do have these little tabs that you can tap on and pry on. I see a lot of students do this, and I know they do this probably because they know these are never going to go back in a vehicle. But once you get it cracked open there a little bit, you don't want to go through and start sticking a pry bar in there and prying this thing apart because you're going to damage the mating surface. With it. There's something that's tight on this one. And usually when it comes up, it pops me in the face. You guys are probably hoping for that, aren't you? There we go. Ah, no, didn't hurt me this time. Boil 1. Acura Trans 0. So, okay, at this point right here, we're looking at the insides of this manual transmission, and get this out of the way. I don't need that there. So, if we take a look here, switch my input over to the side camera, see how well it shows it. This is the gear set that we have. I'll be pulling these out in a second. We have a differential assembly, a final drive. This is a really cool setup, by the way, and we'll look at that separately. I get excited over little things, simple things, but this right here is that oil feed pipe. And you might be able to tell just by looking in there, this guy, this gear, that's the oil pump that I was talking about. And so when it all comes through, this pump generates pressure and it'll pump it up this tube and it'll spray out through these tiny little holes. It'll spray out all over these gears. So that keeps everything lubed up even if parts aren't spinning. Keeps them cool. And then also where this goes into the case, up at the top right here, it goes into the case and there's an oil groove, and it fits right into this pipe. And that pipe fits right down into that shaft. And you can see they have, I don't know if you can see that all right. Yeah, they got little oil holes there too. So it delivers oil onto the inside. And then there's even a separate piece, a little separate section that feeds oil into this. So we got plenty of oil and lubricant going around this transmission, so that's all good. Those are things that if you're not paying attention, it's pretty easy to forget if these are, you're putting this transmission together and you're looking and focusing on the gears and all that stuff, and you put the case on and you look over in the corner of your bench and you've got these pipes sitting there, and that's frustrating. Because I'm going to tell you this now because I don't want to forget to tell you later. When we put these back together, we don't put sealant on or anything like that, but you're going to put a light coating of sealant, and there's like a gasket maker that people use. It's red. It's not RTV. RTV would probably work fine, but it's an anaerobic sealant, and it almost looks like a little strawberry jelly that you put out, and you put like a real thin, like a 1/16 of an inch bead all the way around it. You don't need much, and the reason why is because this is a nice flat machined aluminum surface, and the other half of the case is a nice big flat aluminum machined surface. So if I use something that's if I build up some gasket material on there and I put it together, it's going to ooze 99% of it out, and we just don't need all that possibly floating around. I did pull a manual transmission part one time, and it burned up these the gears where the gears are right on the shafts. When I pulled it out, it had RTV has found its way in through all these lube passages and plugged everything up. So those of you guys that watched the lecture probably saw that, or maybe you will see it. I don't think that's been shown yet in the lecture from where you guys are at. This is the shift mechanism, and so looking at right here, these are where those detents were fitting into, those little check balls. And when I'm moving my shifter, this doesn't work well, by the way, unless it's all together, but when I'm moving the shifter side to side, this assembly here, like I said, doesn't like to work. I'll pull it apart and just show you the pieces. I can pull the center piece out here and put it off to the side. And then I can pull this piece off. So right here on this mechanism, I basically have this interlock plate assembly, and then I have this part right here that can take one shift rail and move it, like first, second, and then I move it over, third, fourth, move it over again, fifth, sixth, so forth. And what it's doing is this interlock plate here, these kind of flat sections, are going to fit in between these shift fork openings here. Like I said, with this not in here and supported completely, these parts don't like to line up very well, but here, you can kind of see where that fits in there. And then this will be allowed to slide side to side, and only it'll lock. These will lock the shift rails that aren't being shifted. It'll lock them in the neutral position, while this one here is going to go ahead and allow the shift to occur. First, second, while locking the other shift rails in the neutral. So that's what this mechanism is designed for. But you got to get it out of the way so that way you can put this together. I'll spin it around. This is the reverse mechanism too. The reverse idler gear, if you will. It's synchronized. And that's the reason why it kind of looks a little more complicated than some of them in the lecture, is because they wanted to include a synchronizing assembly on there, so that way when we shift in the reverse, that you won't get a grind. A lot of transmissions like that mock-up I was showing you before, like that mock-up that we showed you, and you could maybe see in the video, there was a little spur cut slider gear that clicks back and forth. And Tyler Thevna, okay, he actually showed up. I hope you don't fall asleep on me this time. It's all right, we got Jordan there. He'll drop he'll let me know if you fall asleep so I could drop a brake rotor or a torque converter on the bench to keep you awake. I'm going to pull some of the rest of these parts out. This right here is a lever. I can't see it. This right here is a lever that actually moves that reverse mechanism. So it uses the shift mechanism that I had on the side that I just took out and physically moves this shift fork to engage reverse. But I need to get it out of the way so that way I can take this thing apart. Good old Tyler. All right, this is I got it jammed in there, go figure. Normally this is where I start cussing and throwing things. There we go, I got it. So we'll put it off to the side. By the way, if I forget to mention, there's this little like washer that's welded to it. A lot of people accidentally install this backwards, and if they do that, this part right here will like probably end up falling out of its slot there. You can see that big opening, not good. So if you have that installed backwards, now I have no idea why Honda would ever design something that could be put in backwards. That's the way it's supposed to be, so that way it fits evenly in that. But how hard honestly would this have been to make it where it was centered? I don't know. I don't know. Sometimes I think things are afterthoughts. So at this point, okay, I have to pull this shaft out. That's for my reverse. I'm going to pull it straight up a little bit. I'm not going to take it completely out because I can slide this whole assembly off to the side and I can take my shift fork. So that's the reverse stuff, right? We got the shaft that it lives on, the shift fork, the synchronizing assembly. So that moves back and forth. Hard to do when you're just holding it. And there's this little washer. Well, forget that. If you can see, these washers are funky because they're dished. So they add a little bit of preload. So that way if things aren't perfectly matched, when I put the case on, this flexes and kind of takes up the slot, which is good. All right, put that all off to the side. Now I'm ready for the big yank, right? Didn't sound right, I shouldn't have said that. Okay, this is ready for me to pull all those off. See, not many people can do that, just grab in and pull this out. These weigh, I don't know what, 150, 200 pounds, give or take. But I got it, no problem. Okay, so I'm almost got this case stripped out. By the way, one of the things the service manual would have said that I didn't do, but I like living my life on the edge, some of you guys know that, is before you pull it out, they want you to put tape around the main shaft. The reason why they want you to do that is because as you are putting this in and out, you might tear up the main shaft seal that lives in there. But like I said, I like living life on the edge. I'm going to pull the differential case out. Like I said, we'll look at this in a second because it's pretty cool. Most front-wheel drive vehicles do not have that. This is that oil pump we talked about. So if I pull this out, this actually is the gear that drives it. The oil pump lives in there. Let me just pull it out and just show it to you. I'm not going to spend too much time on that, but we'll look at that here. Switch over to my boom. That's the cover. This is where that oil was pumped up through the. Don't want you guys to get dizzy. I see that swinging there. The oil gets pumped up. Hold on a second. Oh yeah, it's smaller. I just finger tightened this last time, so it should come out easy. No black eye, hopefully not. Thanks, Grace, for looking out for me. Thanks, Robert. I'm lucky to have you there. Oh, man, I tell you what, I get more respect doing this stuff on Facebook than I do in real life. And makes me want to keep doing it. So there's the gear. It's a little gear-rotor type gear. And if that pump is being driven by this differential assembly as you're going down the road, that pump is going to be turning. It's going to suck in fluid where we saw that filter, and it's going to deliver it to these outputs that have pressure. So it's going to come out through here, get delivered to this passage, go up to the case, and so forth. I'm just going to go ahead and put it back together. We would inspect it. If you take a look, they have these little kind of holes there. I don't know what you call them, but punch marks. So that way you know you're going to get that gear in the right direction. It might not make a difference if you look at it, but if you take it apart in one direction, especially a gear, you want to put it together in the same direction or else you could end up with noise. There was a little check ball and a spring. It's kind of like a pressure relief, so that way if that builds up too much pressure, we don't create an explosion or anything like that. Don't think that would happen, but really it wouldn't. It wouldn't be an explosion. It's just, there's a pressure limit to everything, right? We don't want this little oil pump to be trying to generate 100 PSI. We just need it to move fluid. All right, so I just want to put that together. I'm going to get this case off of the bench. All right. Not going to have you guys stare at a silver screen. Put the pump gear off to the side. These were my shift forks that I had. This is kind of interesting. When you take a look at these shift forks, they've got like this coating on there. I don't really know what this coating is. Somebody, if you guys know what it is, you can tell me. But man, it's like, I don't know. It's you touch this, it's smooth. It's buttery smooth, like a baby's forehead or something like that. I would say baby's bottom, but I don't think you're allowed to say that anymore. So, but it's like a sprayed on lubricant, maybe a Teflon, but it's there to prevent wear and kind of keep these parts like new. And they've got them on all of it. It's a nice little coating. I like to spray everything down with that. And then here are my gears, the ones that we think about when we think about the transmission. 6 speeds there. And if we look, this is my main shaft. Honda likes to call the input the main shaft and the output the counter shaft. So you can call this an input and an output, or you can call this a main shaft, counter shaft. And on this main shaft, we've got freewheeling gears and we've got fixed gears. The only fixed gears that I have here are these two. And it's going to be used for reverse, first, and second. And then on the main shaft, my third, fourth, fifth, and sixth are all the speed gears. Now if I look at the counter shaft, the opposite's going to hold true. My fixed gears are third, fourth, fifth, and sixth. They're splined to the shaft, and then my freewheeling gears are second, first, and this is that drive for that oil pump. And then this big old gear on the end is the pinion gear that is going to mesh in with my differential. That's what makes the transaxle, right? Is the ability to have this. I guess I should probably aim it the other way. So is having the final drive or the axle part in the transaxle. If you were rebuilding this transmission, and by the way, let's talk about this a little bit. I last night decided to search. For one, parts can sometimes be difficult to find for manual transmissions. It's not one of those things that you can just go out and go to Transtar, or you could. Transtar does sell manual transmission parts, but like their lineup that they might have for late model imports or so forth might not be the greatest. WIT, whatever it takes transmission, they have listings for transmission parts. I searched their part number, nothing came up for this one. They did have a listing there for an Acura. I didn't call them, they might have it. Allstate gear, they've got a lot of Honda stuff. I didn't find anything for this transmission. So where are you going to get parts? Well, the dealer. The dealer does sell parts for these. They sell every little piece that you can get. Now, unfortunately, you can't buy like a synchronizing ring kit. And that's like bearings and synchronizing rings are the common wear items in a manual transmission. You can't get a kit. You can get bearings individually, and you can get synchronizing assemblies that come with 2 synchronizing rings, a sleeve, and a hub, and then sometimes the gear. And those are hundreds of dollars. I mean, they could vary between $200 and $400. So it's not uncommon to go to the dealer for these parts. So a lot of shops, what are they going to do? When they run into a situation where a transmission's bad, they're probably going to go to LKQ and try to find a used one, or they're going to go to maybe car-parts.com, which searches thousands of junkyards across the country, and they're going to try to find a used one. I went to carparts.com. There were like 4 Acura TL transmissions up there. 2 of them were in, no, 6. There were 6. 2 of them were in Canada and 4 of them were in Texas. I kind of questioned the ones in Texas because they all kind of said the same thing. And they were $2,000 or more a piece. So they weren't cheap. And I went to LKQ and they didn't even have a listing for the manual transmission unless I went all the way back to the 2004. If I went to 2007, 2010, 2014, Accord, nothing. So sometimes your option is to rebuild it, and that's your best option. There's nothing wrong with that. I think it's great. Rebuild these things. If all you have to do is change a bearing in a synchronizing assembly, that's not too bad. Okay, so if I were to go through and rebuild these, one of the things I'd want to do first is, before I take it apart, I'd want to check gear end play. And the service manual does, by the way, if you guys are in the drivetrains class, I've uploaded the service manual to the resources section. So this is like the service procedures. I can't go through everything in here. They will literally have you measure the diameter. Drag this over to the other camera. Sometimes the way the gear's set up, you can just put a feeler gauge in there to do this measurement. But sometimes the way everything's set up, you cannot. You'd have to go through and, okay, sorry about that. You'd have to go through, because the way the gear's shaped, there might not be any way to get your feeler gauge between the parts that are controlling the end play. So you're stuck using a dial indicator. Like this one here I'm measuring, that's got a lot of clearance. It's got like 17 thousandths of clearance on that gear. That's a ton. I can go on the gear below it. And it's about 6 or 7 thousandths of clearance. So, and I know you guys might not have been able to see what I was doing there, but I basically had the dial indicator sitting on the gear and I was moving it up and down. And I only measured 2 gears on this counter shaft because these are the only ones I could check. But notice how much you can even hear that one. That's the reason why we check these things, is because even if you don't have a book and you don't know what the spec is, sometimes it's, if you just compare one gear to the next, like let's say if I checked them all on my main shaft and I checked them all on my counter shaft and everything was 5 or 6 thousandths and then I get one that's 15, that's a red flag right there. It's like, okay, something's not right. Maybe there's the component that controls thrust is worn out. Maybe something was misassembled if it's been apart before. In this case, it's possible they have a hex nut on the top here. It's possible that if, I know I don't have this all the way tightened down because I didn't have the right hex key, so I actually made my own. I took a bolt that fit in there and welded a nut on the end. You gotta do what you gotta do at times, and that worked. Matter of fact, I might see if I tighten this. This is reverse threaded. Do you think this will get any better? Or it will stay bad? I didn't see it. It didn't spin at all, so I think it's still off. But something's probably either bad or misassembled in this one. But it's all right. We'll just push that off to the side, not worry about that right now. So we would want to do that measurement for every one of these gears in this transmission. And you can kind of go by feel after a while when you've gotten good enough at this stuff. If you have micrometer fingers like me, you could say 4 thousandths. Oh, that's not good. 6 thousandths. 4 thousandths. That's what a person in a shop's going to do. So, okay, now just for the sake of time, I'm not going to disassemble the counter gear assembly, but I'm going to disassemble this main shaft. The way you get these out, and the service manual will actually show you, pressing this gear off with the bearing, then pressing this gear off, then pressing this gear off. You can press them all off at once. You can't do that on every transmission. You're going to want to watch or look at the service information, sometimes there are clips like that hold one of these synchronizing hubs in place. And if you don't take the clip off and you start pressing on it, you're going to break something. You're going to break the shaft, break the clip, and that's no good. So I read forward in the service manual a little bit when I did it, and I just noticed they didn't have you take anything off. They just, any retaining device off. So I knew I could just go to the bottom and press it all. Now, if I went to the bottom and I started pressing it and started building up pressure, I would have backed off. I would have said, all right, something's not right. And I would go through and reevaluate and maybe do it one at a time. But I'm kind of lazy, so I just kind of like to do things all at once. Mike, do you want to carry that camera around? We'll go over to the press and we'll press this sucker off. Kyle Creech, how you doing there, buddy? Drew, what a good man. Mountain biker extraordinaire that Drew Blair is. Tuning all the way in from Harrisburg, Illinois. Hope everybody's not catching any of the coronavirus bugs or anything like that out there, and everyone's staying safe. That's the whole reason why we're doing this, is because our students are at home, and this is kind of their way to get lab, is to watch me do it. Presses are always safety glass operations. You don't want to get, you could probably lay it right there. You never want to be on a press without safety glasses on, because these parts, they can explode. I've done a lot of things on presses that I've been sketched and scared about, and I've gotten to the point where I've even put like buckets and stuff like that around it, so that way if something did go, it would not only throw metal parts at my face, but also throw pieces of bucket at my face. But anyway, so I'm going to press this down. This is an air-operated press because I'm spoiled. Now, you'll find also in the service information, they say do not use two-jaw pullers to pull these gears off. And the reason why is because if you're on the edges of these teeth with anything, you will chip them. So if you take a look down here, I've got the flat side of the bearing separator aiming up, so that way I'm not going to touch the ends or the edges of the teeth. Because they're really hard and brittle. So they harden these gears so they don't wear out, but there's no flexibility to a hardened gear. It'll chip. So if you got a two-jaw puller, you will possibly chip the teeth, but there's nothing to stop you from buying a bearing separator set from like Harbor Freight, and they've got, where these threaded sections are right here, they've got a bar that you can go up. So you can do this without a hydraulic press. It's just easier. And you can do more damage. You're probably saying, just press the thing off, Boyle, and quit talking. But those of you guys that know me, you know I like to hear myself talk. So you can see it's going down now. There is a pressure gauge up top if the pressure ever got too high. But you'll also hear it in this pneumatic pump. It'll go tut, 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 tut. And that's when you get scared and you back off, because you just don't want something to hurt you. You can see with this, I'm like hardly having to build any pressure. And there we go. Now I won't use a press to push it back together. I'll just pound these gears on. And this is, you try to kind of keep all this stuff together, but look at that. It's a baby boy. I'm going to carry all these parts over to the bench, and we'll resume. Resume. Now, if anybody went through and downloaded, I tried to put this on Facebook, but I couldn't find the files section in the group, the SIU Automotive group. There's got to be a way to do it, but I'm not the #1 admin on there, so maybe only an admin can do it. But these books do a good job of showing you things like this. And this right here is pretty much a breakdown of how these gears are laid out. And this is one of the scenes I had that bogged down my OBS so much. I actually had this kind of on half of the screen while I was in it. And then I made it opaque so I can point through. It was really cool. I'm very disappointed that that didn't work. But Bierman's promised to get me a Cray supercomputer so that way we can make this work in the future. But these drawings are really good if you end up like dropping parts or you weren't paying attention when you're taking things apart, because little sections like this right here that show you the direction that the splines go on a hub, and the fact that there's a is on the top. So, because otherwise it's like, I might put that in upside down if I'm not paying attention. Even that hub, it identifies that hub. Kind of there's a shallow section to that hub. Let me grab my pencil and I'll point to it. There's a shallow section to this hub right here. And then there's a deep section to that hub right there. And this is all good stuff, because if you get confused, now you can usually figure it out, and I'll see if we can't like make sense of it as we go together with it. By the way, they have in the service manual diameter measurements for all these different parts, and they even have a little spot where if you were to lay this on kind of a V-blocks and you put a dial indicator in there and spin it, they'll give you a run out spec, so that way if it's bent. You probably only suspect those things depending on the failure. If you're taking a transmission apart just because it grinds going into gear or something like that, and you go through and you check things and they don't look visibly worn, most people aren't going to go through and check something like that. But maybe if you had a gear noise, it was making like a in and out, like a wah, 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 wah kind of a gear noise, then okay, well maybe my shaft is wobbly in there and it's changing the way these gears are meshing when they're rotating. But other than that, most people don't do every one of those checks that are on there. So, okay, I was just showing you how you could take this apart. I'm going to go ahead and put it back together, kind of in a sequence here. If you notice, and most transmissions are going to be like this. I've seen students mess up on this quite a bit, so it's kind of worth showing that the size of the gears, we're going from basically small to large. So in this case, I didn't show you this before we took it apart, but like I said, first gear is here, second gear is there, third, fourth, fifth, and sixth. And we want to pay attention to that when we're putting this back together. So I'm going to take a look using this little illustration that we have here off to the side. I can kind of, it'll guide me. And I'm going to put my speed gear on. Now, before I do that, I want to talk about the synchronized assembly. You're like, oh, come on, boy, I'll get to the point. This synchronizing assembly is a fancy synchronizing assembly. You're not going to find it in every transmission. But this is the speed gear, and this is the clutching teeth. And if you look, there's no cone surface built into the speed gear. It's actually part of this dual synchronizing ring assembly. And they do this dual synchronizing ring assembly because there's twice as many surface areas. If I look, I've got the inside of this outer synchronizing ring and the outside of this inner synchronizing ring. The synchronizing rings end up lugging together like this, so they kind of work as one. And then the cone has these little ears on them that fit into the speed gear. So what we're doing on first, second, and third gear on this transmission is we're getting the ability to have an inner synchronizing ring and an outer synchronizing ring. So we're doubling up the surface areas on the synchronizing ring. Anybody have an idea why they do that? Maybe I'll just leave that there and I'll see if you guys, uh-oh, I just lost something. I guess, okay, that just came back, all right. That's weird. When you unplug that, anyway. So this right here, post up there in the comments if you know why on first, second, and third gear they might put a double synchronizing assembly. We'll see what people have to say. But yeah, when you go to put this thing together, you're going to have to take all that stuff into consideration. Okay, put this inner piece in, the cone, and then the outer piece on. So if I look over here, switch my cameras over, this is that assembled. Now, before I put this on there, there are measurement tests, checks that they're going to have you do. They're going to have you take a feeler gauge and they're going to have you measure. And you'll see this in the service manual under this where you measure synchronizing assemblies. And I believe, I'm going off of memory, they say 16 thousandths is the minimum service limit, which I think is really small. But basically, if you were to put this thing together and they want you to put this inner cone on and slide it on there, and they want you to measure this gap right there with your feeler gauge. You can see I got way more than 16 thousandths. And then you have you put the outer synchronizing assembly on, and then they measure between the synchronizing assembly and the gear, and I'm once again way more. Usually they're like in the 40 thousandths range, but Honda says the service limit's like 16 thousandths. I would never put one of these together that was that close to 16 thousandths because that just shows how much it wore. So how does this affect? If you imagine, since this is kind of a cone shape right here, if this wears down over time, the outer ring that fits over it, because it matches that cone, it's going to fall further down towards the gear, and that clearance is going to become less and less. Same thing goes true with this outer piece here. If the inner surface of the outer synchronizing ring wears, it's going to fall down further over this cone, and it's going to get closer to the gear. So these dimensions, this dimension that I have between the clutching teeth of the synchro ring and the clutching teeth of the speed gear, they become less and less as this thing wears. So that's the reason why we have to do those checks. I mean, heck, that might be the root cause for this failure, a worn out synchronizing ring. So I'm going to put this dude on. This is my third gear. Then I need to go through and take my hub assembly. Now the hub assembly is also one of those things that you can't just put any old direction. If I look at, this is my hub assembly, and I can see here there's a nice chamfer on this side, and then on the other side I've got like a step. So they do that for a reason. It's not just because, a lot of times these steps are there to avoid a part next to it. Same thing with the chamfer, they might be trying to tuck it into something. And then the hub, if I were to look at the hub doesn't look actually unique. From one side to the other it looks the same. But I can only get this together one way because this is the one that has, I don't know if you can see that in there. Okay, focus on the right spot. Right in there, right where my finger is, it's got a single tooth. It's trying to autofocus on the front of it. And there's a little spot on the hub that accepts that single tooth. So that has to go together that way. That's the only way it will work. And sometimes people fumble trying to get this thing together, and they don't realize that there's a unique way to put these together. So then I'm like, okay, I wasn't paying attention. Which direction did this go? Chamfer up or step up? That's when I go back to my drawing and I look. The step is, the single tooth is supposed to be facing up. So it would be like this. It'd go together like this. When I slide this on, it's an interference fit with the synchronizing hub. I'll have to tap it in. But before I get carried away and start smashing on this thing with a hammer, I want to make sure that these little inserts here are lined up. These Hondas don't have the traditional inserts. They kind of build in an insert on the synchronizing ring. So I'm going to want to make sure that that insert is facing, or is kind of in that slot, because if I start pounding on this thing when it's like that, that little part's going to bump into that. I'm going to damage my synchronizing ring. So I want to make sure that this part here is in this opening. And I can go take a hammer, Scott Pavlonis' favorite tool, and pound on it. Ah, did you hear the sound change? That was a clue. Now I'm going to go ahead and put my hub back on because I took it off. Didn't have to, but I did. You can shift these transmissions after they're together, but I need to warn you. Some transmissions, if you go to shift them, when it's apart and the shifter mechanism's not doing it, and they have the inserts, the little metal inserts with springs and check balls and sometimes check balls. If you go and you just start shifting these things, sometimes check balls fly everywhere. And then you have to take everything back apart because you're just not going to get it back together. So there are some transmissions that you will only want to shift using the shift mechanisms. You won't want to go through and make that shift, like dry shift it there. Mainly because the shift mechanism will only let you go so far, but you can move it as far as the sleeve will let it go, and you might be able to just completely disengage it and let the inserts and check balls fly out. Once again, the Honda is not a concern with that, mainly because they don't use the inserts and check balls. They will instead use these little raised sections on the synchronizing ring. Okay, so this thing also has a double synchronizing ring, so I'd also want to do the measurement and check just like I did on the third gear. By the way, third gear on these transmissions are kind of known to fail. So you would want to look real close at third gear. And they have an issue with gear jump out with third gear. So what do you think you're supposed to do? Well, you're really supposed to inspect the sleeve teeth to make sure that the back taper on the sleeve teeth isn't excessive. I'll just pull this back off. So you want to make sure when you look at the sleeve teeth, the splines there, that they're not rounded off. This one doesn't look too bad. Put my hand there, so I'm hoping it autofocuses on my hand. Kind of catch the little glare, the glimpse of light. So I'd want to check that. By the way, the update for that, they do sell a updated gear. Two problems they have with these transmissions, and one is the first gear, and that updated gear is like $100. It's not bad, and it runs into the same problem, gear jump out. And then third gear, but third gear you have to get with the whole synchronizing assembly, so it ends up being more costly because it's like $300. Comes with the sleeve, gear, synchronizing rings. But I'm looking at those teeth, and those teeth need to be shaped like birdhouses. Or if you're a dark person, you could say like miniature coffins or something like that. But if they lose their sides, that'd be bad. Could maybe draw on this table. I got a clean spot here. Not really. These things don't like to draw on dirty spots, but this is the clutching tooth. Let me try to see if black shows up better. Usually does. That's what you want a clutching tooth to look like. If you've been grinding or if they've been wearing out, you'll wear out this little corner. And then it won't have that back taper. Because what we're looking for is if that's the clutching tooth, right there, and then the sleeve spline will come in and it'll kind of match that back taper. And then when there's pressure up against these two pieces, they actually pull themselves tighter together. But when these transmissions start grinding, and it doesn't even have to grind, sometimes they're just naturally just flexing and wearing through operation, and they wear out too quick, and then they end up wearing this back taper off on the sleeve or on the tooth or both. And then now, when they're in contact, it just tries to push itself out. Half of an arrow there, but that's the reason why we need to pay attention to those clutching teeth on every one of those gears. If they've been grinding, a lot of times that the nose of that little clutching tooth there rounds off. And that makes it sometimes difficult to shift because you've got to round it off. You don't have a good point to let parts slide by. All right, hopefully that makes sense. Oh, Sean Pelgen, he's calling me out on that one. He says those diagrams are great if you're in class and someone moves all your parts out of order overnight. Who would do that, right? I mean, I feel like you're looking directly at me when you're saying that, when you're writing that, but I wouldn't do anything like that, at least not with witnesses. So we're going to go ahead and put third gear back on. Sean, he's a smart guy right there. and with a good name. He just spells it wrong. Oh, one of the things, I know you guys are like, come on, just put it together. I wanted to show you this is, switch over to the overhead, is when you start going together with some of these things, you'll notice, like there's a set of splines under this hub, and the surface of that hub is like flush with that set of splines. And keeps defaulting to that, but anyway, that's actually a good indicator. You're like, oh, I see where this hub is about flush with those splines, so that gives me a good feeling inside, like I might be, like parts might be going together right. And I'll see that throughout. Like if things are going together the way they should be, I'll start seeing things kind of line up. So I've got this gear on. I want to slide my, what would that be, 5th gear. And now I've got this synchronizing assembly. This synchronizing assembly is pretty generic. It just has one, because we're getting up into these higher gears, and you don't need the synchronizing assembly to be as strong. It's not, there's not as much torque going through it, not as much speed matching. So it's just a simple little single synchronizing ring. This is what you usually see on a lot of transmissions. And you still measure it the same way. I put this on there, and with pressure down on it, I measure the gap. And I can see here, that's a good 45, 50 thousandths. So this is probably good. On the inside of this, you'll also notice that there is the clutch, it's got clutch material instead of brass. Still trying to get it to zoom. So this material right here on the inside, that's like a friction material. It's not, that's not brass. It's basically a cellulose. It's the similar material that you'd find in a automatic transmission. Okay, so here we got that. We're going to put it down on that. Want to make sure my little teeth end up fine. Oh, what am I doing? I got that upside down. Don't worry. We'll have to edit that out in post. Now we're ready for my last synchronizing hub. Once again, this guy here is going, it looks like the hub is the same, both sides. It's got equal, it's got a step on both sides. Not the hub, but the sleeve. The sleeve has a step on this side, has a step on that. So the sleeve looks like if you accidentally got this backwards, that'd probably be all right. But the hub is a little different. If you look, this is shallow, and then tip this around, it's much deeper. This part sticks up a lot higher, and that's kind of a deeper ledge. So if I flip this hub, I'd definitely have problems. So I wouldn't want to do that. So when I go together with this, I want to make sure this is going the right way. I can look at my drawing, and it would give me an indication, but I can also tell using common sense. This is the shallow side, and if you look at what this goes up against, it'd have to go this way because there's not much of a drop to get into this gear. Whereas if I flip it over, the part that's deeper, that this sticks out further, well, on the parts I have assembled here, you can see they're further down. So I'd have to believe, and I'll verify it. Yep, I was right. So I took a look, and my theory held true. Same thing here, though. When you go to put this in, you want to make sure the inserts portion is opened up to the slot in the sleeve before you pound this on. And I felt like it just dropped all the way in, but I'll give it a couple taps just in case. Yep. Sometimes they give you a little bit more of a fight. Once again, kind of double check my visual reference there. You can see that you can barely see a little bit of that spline section there up against the shaft, and it's matched up with the top of this surface here. So that's good. That's a good sign. Now I'm going to go ahead and put my last gear in there, 6th. Make sure the splines are lined up, or the teeth on the synchronizing ring. Probably the number one cause of damage in the drivetrains class. Some of you guys might have experienced this before, is not having the insert grooves for the synchronizing assembly lined up in those hub slots And then when you start pounding things on and you damage the synchronizing rings. You basically end up jamming that synchronizing ring up against the gear, the cone surface, and you also screw up the brass around that little area. And it just, or the other part is people just accidentally assemble a hub upside down or a sleeve upside down. And sometimes the transmission will let you put it back together like that. That's bad because it will fail. It won't work out there if it's not together right. Oh man, that just slid on like a dream. So here we go. This is the main shaft. When you're done, every one of these gears should spin. And if you've checked your end play, you should double check, make sure they're all the same. Unless you've changed a hard part, most of these would pretty much be the same. I'm not going to go through and do the same thing on this because there's really nothing different. You have to take this bolt off and then you press all that off. So we'll leave that. But here's something cool. I want to show you this. This is the final drive. But this final drive they've got in here has a helical gear set in it. It's a torsion type gear set. So I'm going to pull it apart real quick. Now, I will tell you this. This is not rebuildable. If there's damage in this, these are just gears. So if it's bad, and you'll have to get a new one. So, I didn't tighten these up to spec. Normally they'd be way tighter. I probably wouldn't be able to loosen it with my 10-year-old Chicago pneumatic 3/8 impact that still use nickel metal hydride batteries. But you know what? We got these for free. And thank you, Chicago Pneumatic. How many did they give us? Like 5 sets of those? I want to think I might be the only one that still has it laying around. But beggars can't be choosers. So this is the diff case. And they've got these 2 screws in here just kind of holding these 2 halves of the case together. And this thing is, some of you guys might have some experience with these gear sets. Quaife is a company that makes them for front wheel drive vehicles. They're LSDs, limited slip differentials. But this is a factory piece. It comes with this on the Acuras and Honda's, the Civics, I believe. I don't think it comes in the Accord, but I might be wrong. Believe it or not, this was only like $300 if it failed. So, switch over to the side camera here. This is that setup there. Oh gosh, I didn't like that. And so we don't see side gears, we don't see differential pinion gears. What we do have side gears, but they're these guys. And so this is splined to 1 axle shaft. Then we have these long and short pinions. Man, I hope I remember how to put this together. If not, I got a video showing me, right? And then this is the other axle shaft. So I got my 2 axle shafts here. This goes to the one side, right or left. That one goes to the other axle shaft. And then we connect these 2 side gears together by using this, all right, how did it go? Let's see. We connect these 2 side gears together, doing this weird, by basically having this, here we go. Yeah, I gotta kind of hold this one further away. So, no, okay, yeah. One sits lower than the other. But we connect these 2 side gears through these helical cut worm gears. And what will end up happening is when one wheel wants to go a different speed as the other, these parts are going to try to split apart from each other. And when they split apart from each other, the friction that occurs on the ends of these gears up against the differential case is what's going to provide my kind of limited slip. And how they shape these gears will change what they call the biasing, so they can actually affect how how much torque is transferred from one wheel to the other. So this is not something that you can rebuild, as you can see. If something broke in here, I would end up having to replace this whole assembly. And what ends up happening is when I'm in a one-wheel slip, I don't really get one-wheel slip situations so much, but when the differential case is receiving the torque, it delivers it to these gears, basically, and then those gears deliver it to these side gears. If one wheel wants to spin a different speed as the other, it can, but it's going to have to cause these side gears, these little torsion gears, to rotate. And when they do, because of their kind of helical, really steep helical gear nature, they're going to want to thread apart. And the force of the ends of these gears contacting the case is what provides the resistance and makes it not want to spin, basically, and wants it to continue to go with the differential case. I know it sounds real confusing, and it is, but it's one of the few ways that you can get limited slip on a front-wheel drive vehicle, because most front-wheel drive vehicles aren't going, you can't use like a clutch type or a cone type limited slip, and you don't want to use a locker, because if they actually started to drive the inner wheel while you're turning, it's going to try to straighten your steering wheel out, and you're going to get an understeer situation. So you have your turning wheels, so you're always going to have to be able to allow the wheel speeds to deliver, or the wheels to rotate at different speeds. But if you want limited slip and you want to distribute torque evenly or at a ratio between both wheels, that's where these come in. It's not only used for front. We talked about this a little bit, I think, in the rear axle lecture, but they do, some manufacturers use these in the rear. Dodge trucks, believe it or not, used them for, I think they still do in the rear, if you got a certain option. The old Camaros had them. The Humvees have them. So there are a lot of applications. They're also in a lot of transfer cases. And so you actually have to build this thing up kind of like on this half to get it back together. You can't put this in. You won't be able to slide these gears in unless you build it this way. It's kind of interesting little setup there. Anybody got one of these in one of their cars that they know of that's watching this? Because they are pretty neat options. You might not even know it if you had it in your car, because unless you know your car real well, it's not like it's something that you can tell readily. Your car will still drive normal with this in there. Trying to go. Okay, watch my fingers. Oh yeah. Oh, I'm all right. I got it. So, comes apart, goes together easy. You'd want to take it apart to clean it if you had a lot of metal in the transmission when you're overhauling it. So it does come apart and go together fairly easy. But like I said, if there's something wrong, it's not like I can replace the clutch pack in there like we can on a rear axle limited slip. It's either good or it's bad. I asked one time if I can get one of these from the Chrysler Training Center, and they're like, well, the only ones we ever get are exploded, so there's nothing worth showing. So that's this, limited slip, LSD. Not the drug, but the differential. Oh, Thaler's got one that's not stock, okay. Hey, Brian Quinn. Got Ryan Barr, hopefully still working at Bosch as a trainer. Does Bosch make anything for a Acura manual transmission? Or I don't think so. Bosch makes something, heck, they make dishwashers, you know? They make just about everything. But I don't know about manual transmission parts. They probably have something in their automatically shifted manuals. Just gonna snug these up. These are training units, so you can see I avoid things like sealant, torquing. And I do so for a good reason. It's not just because I'm lazy, which that's part of the reason, but the main reason why is because I don't want these things to get worn out. If we're always torquing them down in class, this wouldn't be a problem probably, but aluminum threads in a case, that would give you, it just would strip the threads out, and then after a couple years, all I'd have is a helicoiled case everywhere. But okay, so let's see, what did we go through? We took apart a main shaft, and we looked at the synchronizing assemblies, and we showed you how to measure to see if they're worn by measuring the gap. And by the way, you don't have to completely take it apart. I could measure some of those measurements right here. On these synchronizing assemblies that just have one synchronizing ring, I could push on it and stick a feeler gauge in there and check it. If I have the dual cone set up, I'd be able to check the outer cone, but I mean, if the inner cone's worn out, so would the outer cone. They're gonna wear evenly. We pressed these parts. We showed you that there are measurements that they do on these things if you needed to. We looked at the differential case. Because right now we're gonna go ahead and put this thing back together and wish me luck, right? Throughout, when you do an automatic transmission or a manual transmission, it's pretty common that you're gonna want to check your bench throughout. So that way you don't get too carried away and you put all this stuff in, you look over and you forgot something that had to go in first. I don't know how many times I've taken put a transmission together and I was like, man, that went together easy. And I didn't have the differential in there. So that's kind of embarrassing. How do you miss something that's that big? Sometimes it's just because it's sitting right in front of your face and you don't even notice it. You look for the small stuff. You don't see the big stuff. You don't see the forest for the trees, right? Is that how the saying goes? All right, and then, so I got that in there. Now I got to drop in my main shaft. Remember, they'd want you to put tape around that so you don't end up screwing up this seal going in there. So before I drop this in, I got to line up my shift rails, all that good stuff. And this is actually a good point to double check your alignment of your gears. If I laid these two right next to each other, these gears should be pretty even across. You know, there shouldn't be any, like this shouldn't be sitting 1/8 of an inch or 1/4 of an inch higher or lower than the one next to it. They should be right across from each other. Okay, and that looks, I'll just assume that's good. And then I'm going to take my shift forks and I'm going to put those on. Let's see, okay, this goes that way. This part here fits kind of around the shaft. I've seen where this ends up, you go together and that's like over here and you realize, oh, take it back apart, because that kind of keeps this part of the shift rail assembly and the shifters aligned up. How many times can I say shift there? And there's my other one. So I put these together, make sure they find their way into the shift sleeves. And I hold them all kind of together there. Oh, got all country on me for some reason. And then I'm going to take a look real quick. I think I'm ready to plunge it all in there. Takes a very steady hand. You don't want to get your fingers somewhere where they can get chopped off. All right, so this is in there now. I just drop that in, and I look at the gears now at this point, and I'm like, man, every one of these gears are low. But then I realized that snap ring that I had to open up when I spread the case open, when that's sitting where it's supposed to be, it'll lift it up, and it'll be perfect. It'll be perfect. All right. That all looks good. Look at my bench again to make sure. It's like, oh, okay, I'm going to go ahead and put these tubes in now so I don't forget. These are the things that you don't want to bang around because that has to find its hole on the other end of the case. And if that's bent, good luck trying to figure out where that's supposed to go. That one fits in there. It's got to find a hole in the end of the case too. Normally I'd spin this around, but trying to keep it in the view of the camera. And this reverse stuff here, they've got their own little parts and pieces. So we didn't really talk much about this, but there is a layout. We did look at we've got the little fancy washer, and then there is kind of an outer roller bearing race and a bearing race. Now lives on the bottom. When you take it apart, there is a blow up in the service manual that kind of shows the orientation of all this. But we have a synchronizing sleeve, and a cute little synchronizing ring. Look at that. See a little synchronizing ring? It's darling. I'd like to hang that little guy from my rear view mirror. That'd actually be kind of cool, right? How many people do you think would get that if I hung that from my rear view mirror? But I could still do my little check with the feeler gauge in there. These two gears are separated by like another set of a washer and a couple roller bearings. If I got this mixed up, I didn't have a service manual and I had to use my intelligence to figure something out, I could look at this sleeve, and if you notice on this side of the sleeve, if you look back there, there's not clutching teeth, it's just square. Or not clutching teeth, but the splines are just square. They're not like shaped with a point or anything like that. If I flip it around, you can see this side does. It has these little points on there. What's the point, you say? Well, the points would go towards the gear that I'm engaging with the synchronizing ring. So I'd know this goes in this way. Otherwise, why would I put these blocky ones up against there? On the other side, it doesn't really do anything on that side. So it just kind of slides over it. It doesn't have to match these gears. This is kind of like a gear / hub assembly. Hold on a second. Got this thing jam-a-lam ding dong down there. Were you guys paying attention to how this went together, I hope? This also, one of the things, I know I won't be able to show you on camera, but two of these spline teeth are bigger than the others, and then they have two slots. Two slots that are shaped with like a deeper groove. Right in here somewhere. And then there are two teeth that are bigger. And that's how they orientate, is that a word? So that way when you get it right, it just falls right on in. And they're just slightly different. So it's one of those things where if you're not used to looking at it, you'll probably do what I'm doing, fiddle farting around until you figure out, dang it, the alignment. You guys having fun, probably. Watching me struggle with this. Get in there. Oh, there we go. All right, I'm going to build it this way, so maybe it's a little smoother. Put that on, synchronizing ring on. Got that in place. Ooh, I need my bearings in the middle here. There we go. Got a nice smooth fit there now. Kinda. Basically, if things don't seem right, they probably aren't. Put the wrong bearings in. Come on, where were you guys on that one? All right, here we go. There we go. Okay. Perfect, man. It's excellent when things go together as planned. Yeah, I'm barely on the screen. Okay, so this thing has a dish. And you're like, which way does the dish face? Sometimes you can see the wear marks on the case, in case you didn't know, but the service manual has that information too, so you can always look at that. In this case, the dish kind of curves up like that, like you have a dinner dish upside down. So dish down is what you would say. All right, so this here, I could slide this in with my fork and drop it in place. Maybe. I'm waiting for that. I'm trying to get the shaft to drop down in there. And I might be hung up on a short. There we go. Perfect. Okay, now I need to put the shift linkage for reverse in there. And that was this piece right here. And if you remember, that was the one where I said that welded washer needs to kind of face out, or else this will be, this piece that fits in there will be spaced too far out. And that wouldn't be good. Get in there. So I'm working from the opposite side of this unit. That's why it's harder for me. That's my excuse, at least. that I'm going to use, because I'm trying to favor the camera so you guys can see it better. But that's my excuse. Okay, so right now this is engaged. Ta-da! Now my reverse will work. Beautiful. Looking good. I'm going to look at my assortment of stuff I have here and see what I'm forgetting. So I don't want to drop a case on unless I have everything. This is the mechanism that ends up hooking up to my shifter. And if you remember this good old stuff here, it fits into this area right there. And if you don't pay attention when you put this in there, you might let this be dangling down and it won't grab onto the parts that it needs to grab onto, which is this groove right there. Is that groove? Right there. So that fits inside this little spot right there. If I don't pay attention, I put it together, this isn't even going to grab on anything. So I need to make sure this is up and it falls into this. Then I got to wiggle these parts in there until it goes into place. And you know, honestly, you're like, well, how am I going to remember all that? You don't have to remember any of this stuff because you're not gonna. You're just going to remember the important parts. What measurements do you need to do and all that kind of stuff, because every transmission is going to be a little different and they're all going to have their own little details. Unless you do this stuff all the time, you're not going to be familiar with every transmission as you go through. So now that's in there. So this becomes the fun part right here. It's where I've got to go through. I've just scanned this. I don't see anything else that needs to go in to the inside of the unit. So it's time to drop the case down. And surprisingly, I'm going to remember to mention, normally you would put that anaerobic sealant on there. And is it aerobic sealant or anaerobic? I think it's aerobic sealant. It needs the presence of oxygen to set up. So because of that, anaerobic sealant will set up without the presence of oxygen. Aerobic will set up with the presence of oxygen. But the aerobic sealant does a good job of making a thin gasket between these two machine surfaces. It works great. So what the big key is, though, and this kind of makes it a rush, if you put the sealant down on here, you got about 5 minutes that you're supposed to get these two parts together. If for some reason you're fighting it and it won't go in, or you have to take it off, you have to scrape all that sealant back off, clean it off, and put some new stuff back on it. So we're going to try to drop this here case down on there and see what happens. This part right here is the part that I'll have to fumble around with. This little shifter, because it is going to fit into, as I drop the case down, I have to get it to fit right into this assembly right here. So as I go down with this, as I go down with it, I have to actually slide this shifter right into this. So this will end up, I'll have to like kind of guide that in there. It's not as big of a deal as I'm making it sound, but I like to, you know, make things sound tougher, so that way you're like, wow, good job. Okay, so here we go. Wish me luck. Oh. When it gets to a point, it's trying to, it almost like these, especially these Hondas, they like never just drop right down in. So one of the things you'll never want to do is use a bolts to pull it down. You'll break something for sure. If it's not dropping down, there's a reason. A lot of times I'll take a screwdriver and I'll just go into the shift holes and where the detents go into, and I'll see if those are fighting me at all. I'll jiggle my shifters around back and forth, and then I might take a soft face hammer. I might just be fighting a bearing, and I'll give it a few love taps around. Not a ball peen. A little tippy tap. I'm looking through this opening. I can see it dropping when I do that. And I'm kind of guiding my shifter in. I can feel it trying to do its thing a little bit. And then, you know, like I said, jiggle your shifters around, see if that helps. Oh. Got something going. Yeah, now I'm back on to my, right at the top where I had that snap ring. Right there, I'm back on. I could see the bearings pushing up on. That's what I was looking through and seeing the case drop down. So I got to expand this out and then grab my little soft face hammer. Look at that. That was the part that I was thinking was going to fight me the most. And it seemed to work all right. That did not pop in yet, but it probably will once we get this thing together. If not, I spin it over and I let gravity kind of do its work there, and it'll click in. So before I ever put this cover on, I'd want to make sure that that was in the snap ring groove. Now here I'm going to just put a couple bolts in, and before you tighten anything up, I'll go ahead and put 4 in. Before you realize, if you have sealant on there, this is all stuff that has to happen pretty quick. But the 4 bolts are just going to keep all these pieces in place. And I'd want to get down and look and make sure that these 2 seams are touching, that there's no gap. If I see any gap, that means I'm going to be squeezing, I'm squeezing 2 parts together. I'm going to sandwich these pieces in there and cause damage. And that's not good. I don't want to do that. Okay, so I got 4 screws in there now. I can go ahead, and the reason why I did that is because I want to be able to make sure this thing spins and shifts through all the gears before I go through and put all the bolts in there, and it takes all that extra time. So I can, it's smooth, it rotates, go between my gears, and then, you know, there's first and second, nice and smooth. Third and fourth, nice and smooth. Okay, well, this one's touchy. It's not the train. Oh, there we go. Fifth and sixth, smooth as glass. This is so good, I'd probably put it in my wife's car. Reverse. It's got all the gears right there on the first try. At this point, I could put all the rest of the bolts in. And then I want to go through and drop my detents in. Remember, and really, I don't have to go through this any further, just kind of for the sake of time. But remember when I put my detent screws back in, that I've got these longer springs, and they're going to go in their little spots. And then I have shorter springs that go in there. So I can't just take any old assembly and expect it to do its thing. I've got short springs and long springs, and I need to make sure they go in their right spots. Matter of fact, it looks like I have 3 different length springs here. Well, definitely 2. So this dark one looks like the same length as these gold ones, which is surprising. I don't know why it wouldn't be gold too. And here's another. So those are my 6. I have 2 short ones and then 4 longer ones. And the service manuals will identify that, but hopefully when you took it apart, you were paying attention and you identified that as well. All right, roller bearings are inside gears between you. Okay, thank you, Tyler. You helped me out there. Didn't fall asleep yet. He's kind of got a reputation around here, but we'll leave it at that. So now I want to show you guys something here real quick, because everything's real quick with me. The clutch spin down test. Some of you guys are in my class. You might not have gotten to that point where we're talking about diagnostics, but you will. And there's a video up there, but I'm also going to demonstrate it to you. I made a video on the Corvette yesterday, but I left the memory card here, so I wasn't able to edit and make it ahead of time so I could show you. We do have a Subaru Wrx, thank you Ally, that we recently got. I'm going to try to do it on that vehicle. I will warn you that this one, it's not really a warning, but I'll just let you know that this vehicle is a little touchy, so it doesn't work as well as most vehicles I've checked. The Corvette worked really well, but I might post that video up later. But this is called a modified clutch spin down test. And Mike, maybe we'll go over here and I'll just show people what we're doing first on one of these mock-ups. The reason why we do a clutch spin down test is because we want to know if we're having a hard to shift complaint, is our clutch system dragging? Is it not fully releasing? If you remember when we push our foot down on the clutch, that pressure ring pulls back and it completely releases this clutch disc. But if this clutch disc doesn't fully release, it's going to drag and it's going to be spinning these gear set parts. And the gear set parts are, the synchronizing ring's job is to match the speed of the gear to the shaft. And if the clutch is dragging, not only does it have to match the speed of these mechanical parts, the gear and the shaft and the clutch disc, but it also has to overcome whatever drag our clutch is doing. So the service manuals will have you do things like a dynamic shift test, where what they'll do is they'll say, shift the transmission, start the vehicle up, put the transmission in neutral, and take your foot off the clutch. Let all these parts spin, and then push your foot down on the clutch, shift it into reverse, and it would work possibly on a transmission like this, the way they have it explained, because the reverse is a slider gear and it's not synchronized. So what they're saying is if it fails this dynamic shift test and the clutch was not fully releasing, when you go to shift into reverse, you'll hear it grind, because there's no synchronizing assembly there to slow the shaft down or match speeds. Now if you did that on vehicles that were built in the last 20 years, that dynamic shift test would fail because almost every transmission has a way to stop the shaft from spinning, or it has a synchronizing assembly, just like that Acura 6-speed that we have. It has a synchronizing assembly for reverse. Remember, the purpose of a synchronizing assembly is to work as a clutch, not this type of a clutch, but as a cone clutch, to grab onto the speed gear and force it to go the speed of the shaft before it lets the sleeve engage the gear. It will block the shift until speeds match. That's why when a clutch doesn't fully release, it's hard to get into gear, because the synchronizing assembly is doing its job and it's blocking it. If it was easy to get into gear, you'd hear a grind and chunk into there. Now, some of you guys might have vehicles that do have issues with grinding into gear, and that's usually because the synchronizing ring has worn itself out trying to match speeds from a dragging clutch over time so much that it wore out the synchronizing ring and it just can't do the job of matching speeds anymore. So how do you check that? Especially on a modern vehicle where you don't know if you have the slider type gear, you're just wanting to diagnose this. Well, I've invented, feel free to use as much as you want, a modified clutch spin down test. Whereas this is the clutch spin down test, this is the modified clutch spin down test. So what I'm going to do is I'm going to take a gear, let's just say first gear for example. You will shift into, this isn't first gear, but it's easy to see. You'll shift into that gear and you'll have the engine running, push your foot down on the clutch, shift into the gear, and then shift halfway out. At this point, your sleeve is over the synchronizing ring, but you've disconnected the clutching teeth. So and I can't really demonstrate it very well on this, but you should be in neutral if you've disengaged the clutching teeth. And when you try to engage the gear, you can hear it a little bit. Hear it grinds. You let it kiss and grind, so it's making that noise just a little bit. And then as you push your foot down the clutch pedal, you'll find out exactly at what point the clutch released. And you do this with the engine running. So we're going to start with this WRX. Now I'll tell you one of the reasons why this thing is going to be difficult on the WRX. I don't know if this is typical. This one we got, it was an insurance buy, it was an auction vehicle. Wait, came from an auction house. I got it because it was what's the deal, Mike? Insurance?
Yeah, it was a buyback flood.
It was a buyback from a flood vehicle. So we got 3 vehicles from them. They support us real well. We get a lot of graduates that go to work for Ally as claim specialists and working at the main office there. This vehicle seems to work perfectly fine, but when I start it up, the idle, it'll go straight up to almost 2,000 RPM and it kind of hangs there for a while. Well, maybe if I warm this thing up, the idle would drop down to a normal speed. We'll see what happens as we go, but it's a little harder to do this when the engine's spinning fast, because as I get it to make that little grind sound, it's going to kick out at times, so bear with me. But actually, before we start, I'll grab that light, Mike, and see if, in case we need to shine some light on the subject. So the spin down test is something that you'll do to find out if your clutch is fully releasing. This seems like it'd be a pretty fun vehicle to drive. It's always nice to get manual transmission equipped vehicles too, because we don't have too many in the program. If you'd like to donate one, please let us know. All right, there we go. I'm just trying to raise so I can see these pedals. They're way down there. I'm gonna do it with my right foot because that way you might be able to see the pedal more. I'm gonna start the engine. Yeah. Oh man, not flexible. Are you able to see the shifter at all?
A little bit.
Okay. Okay, so I'm in neutral right now. So if I take my foot off the clutch, a neutral. If I push my foot down, it's idling at 1800 RPM. It's slowly starting to drop. But I'm gonna push my foot down the clutch, and I'm going to push it into gear. So right now, if I took my foot off the clutch, the vehicle would want to move, put the parking brake on. And if I slide it halfway out, take my foot off the clutch pedal, I gotta get past. I gotta release the clutching teeth. Okay, now I've captured the synchronizing ring in the synchronizing sleeve. And I'm going to move it forward, and now the synchronizing ring cannot block the shift anymore because I'm already past the synchronizing ring. So if I start bringing the shifter forward, hear the grind? See, it pushes it. The high idle is killing me on this thing because it kicks it out. There we go. I got a better video with the Corvette. I didn't bring it home to edit it. And I was just going to show that because I don't know why this thing idles. It's 1700 RPM still. Anybody got Wrx out there? Is that normal? It doesn't have any check engine lights on or anything. What I'm doing is I'm trying to find that sweet spot where the clutch releases and you don't hear that grind. So like I can hear the grind. If I push my foot down the clutch, I'll be able to tell exactly at what point. Hold on. I'll be able to find exactly at what point this thing stops or releases. Right here. It sounds horrible, doesn't it? Can you see my clutch pedal all right down there, as far as you can tell? So what I'm doing is I'm taking my foot and lifting, I'm halfway, I'm letting the synchronizing sleeve teeth just kiss the clutching teeth on the gear, and I'm letting my foot off of the clutch just a little bit. And I can feel exactly how much extra clutch travel I've got.
There, your idle's down now.
There we go, let's see if that helps. That only took forever, didn't it? I'm in gear right now. Okay, there it is. So sounds horrible. The sleeves are touching the clutching teeth, and right there it stopped. So from here, from my foot down to the floor is extra clutch release. I'm gonna lift it back up, let it grind some. Find out exactly when this clutch engages. Right there. Oh, I went into it. Not something you want to do in front of a customer. They probably won't appreciate it, but if you're trying to diagnose a clutch that's not engaging or maybe dragging, Right there, the clutch is still driving. And at that point, the clutch is released, and then from here to the floor is
About 4 inches.
about 4 inches. Okay, that's not bad because I got probably maybe 6 inches of clutch pedal travel and then 4 inches of reserve. And the Vet, I probably had about 3 inches, but I don't think my foot had to move as far. But it's important because this is what the dynamic test that we described earlier, where if you push your foot down and try to engage reverse, and if you don't hear, check to see if you have a grind. For one, that doesn't work if you've got a synchronized transmission, because the synchronizer is there to try to match speeds, but also you're pushing your foot all the way to the floor. So what if you lift your foot an inch off the floor and it's already trying to drive the vehicle or spin parts? That's a problem. That's not good. So a spin down test like I'm doing it, where you're pulling it halfway out of gear, and then you start moving the sleeve towards the speed gear and let it grind. And then when you push your foot down, you hear the grind stop, and then go from there down. That's the excess or extra clutch movement. So that gives you an idea of how to evaluate at what point your clutch fully releases. And I know that sounds brutal, but realize what we're doing to this transmission. We're just letting these parts just kiss each other. They're not like, we're not sitting there making all kinds of metal. They're just rubbing up against. There's no torque traveling through it. Oh, one other thing I wanted to mention, because most people are unaware of this, that synchronizing assemblies, and I showed this on the Vet too, but I'll show it here, that if I try to go in and start this vehicle up and just go to first gear without pushing my foot on the clutch, what's going to happen? You're probably, some of you are like, oh, it's going to grind. It's going to grind like crazy. It won't do it unless my synchronizing ring is worn out. Remember, the function of a synchronizing assembly, it positions itself in the sleeve, in the path of the sleeve until speeds are matched. And then once speeds are matched, it actually backs the gear up the opposite direction to let it go through. So as long as the speeds aren't matched, the synchronizing sleeve ring blocks the sleeve. It won't let it go through. And I can prove it. It's in gear. I got my foot off the clutch. I'm gonna push on this. Now, I got stuff in front of me, so if it did go, I'd be causing some damage. And this is live. So if something did happen, that'd be one for the blooper books there. But you'll actually see when I push this forward, you're gonna see the vehicle kind of move. It's actually just the synchronizing ring, the clutching action that's occurring on the synchronizing ring, grabbing that cone surface is going to try to move the vehicle. But look at that. See how I'm moving? I'll go slow. See, I can move a rocket back and forth. That's second, not going. Third, not going. Fourth. It blocks the shift. I cannot get it in the gear until I push my foot on the clutch. So synchronizing rings, they will block the shift until speeds match. That's how they're designed. Now, mind you, if this car had a worn out synchronizing ring, it'd grind like crazy. It would have been a bad deal. But these things, they don't have any issues with them, so I could show you what normal is. That is not a diagnostic test. You're not going to go into a customer's vehicle and say, okay, I'm going to just see if it'll go into gear without me pushing the clutch in. The only reason why I did that is so that way you can just kind of to prove that these synchronizing assemblies block the shift until speed's matched, then the gear backs up half of a tooth and then allows the engagement. And they do have to back up. That's the reason why if it's rotating in this direction, the teeth are lined up and it actually has to stop that rotation and then back it up a little bit to go past. So let's see if you guys have any questions on this. What's going on so far? I haven't seen anything recently. We've got some people. How do I teach common sense? I don't know how to teach common sense because I pretty much don't have it myself. So that would be a good lesson for all of us to learn. Preston said, why not use an air hammer, then process will be accelerated. to, I guess at what point were you asking? Not really certain. I don't know. Air hammers, they're pretty brutal, and they can do a lot of damage. Are you thinking pulling gears off or something like that? I do know a tech that at a shop uses air hammers a lot, and he will vibrate. He'll put something on a shaft and put a little pry bar and then use the air hammer to create a vibration. And a lot of things that you need to press, you could just vibrate off, and that's always pretty impressive. But I don't know. I don't know if I would jump into that air hammer thing. But Tyler is talking about speed differences. Okay, somebody looked at my bigger step between the gears and lower. Bigger step. It's likely. Okay, I asked the question. What question did I ask? I'm trying to say, oh, okay, yeah. It was why do we have the double cone synchronizing assembly? And it's because, and it's true, Tyler's like, there's a bigger step between gears with the lower gears that when you think of the RPM changes that happen in first, second, and third, and so forth, but also because those things are, when you're driving, you're revving the engine up, and then you're shifting. There's big RPM changes, and I think that's what Tyler's getting is the bigger step between gears. But also there's more torque going through this gear set, and I'm kind of expecting quicker and faster shifts. So if I put more, a double cone clutch assembly in there, my synchronizing assembly can grab onto that speed gear and force the speed change quicker when I've got twice as much surface area because I got a double, and they even have triple cone setups too. So, and you just don't have that RPM difference. When you're shifting from fourth to fifth and fifth to sixth, your RPM changes are much smaller. You might be going from 2200 RPM to 1800 RPM or something like that. Whereas first gear, you might be revving at the 3500 RPM and bringing it all the way down to 2000. So you want the better synchro, smoother engagement. It is, yeah, it isn't accurate. Now Jake said use 3 jaw pullers. The number of jaws when pulling those gears off don't really make as much of a difference. It's where they're contacting. You just don't want to get, I don't have a gear in front of me. Where's that burnt gear, Mike, that you were talking about? This isn't from a automatic, this isn't from a manual, it's from an automatic, but the idea is that you just don't want to get onto the corners of these teeth here. If you get onto the corner of the teeth, that's going to potentially get you to a situation where you end up breaking a gear part. So it's the idea of making sure the pullers are grabbing onto, like, way zoomed in. Instead of like here, you need to be back here on these smoother parts. So you could use the bearing separator and then use a 2-jaw puller on it, or use the holes on the bearing separator. If your 3-jaw puller came in and kind of looped up and wasn't contacting the actual tooth, it was kind of getting in, it would work fine. 2-jaw puller or 3-jaw puller, I'm sure it'd work perfectly fine. So there weren't really any questions on the YouTube channel, but you guys can ask me anything right now. Oh, buttery smooth, just like the East Side mountain bike trails. Well, Drew, the East Side mountain bike trails are rocky, rutted, and horse-pulled, and just halfway destroyed. So okay, I'm as smooth as those. Okay, but all right, if there's no other questions, and I can answer some of these things through comments afterward, but this has been going for 2 hours and 15 minutes, not too bad. That's about as long as the rear axle one, and took apart and put back together a complete manual transmission and covered some of these other parts for you. So comment up if you have any more questions. If not, we'll do another live stream probably, I don't know if it's next week, but it's going to be on the drive line, maybe U-joints, drive line angles, a couple different checks that we can do on the drive line. So I appreciate you guys watching, and hopefully some of this stuff cleared up a little bit of the mud. If those of you guys that aren't in my class are interested in those lectures that I'm covering, I can maybe send those to you, some links to you or something like that. Just send me an email, jeepster@siu.edu. All right, thank you. All right, my mouse is over here. Thank you. Thank you.